everyone, and welcome back to the Information Bottleneck. And today I'm really excited. We talked a lot on this podcast about RL, about agents, about how the field is moving from pre-training to post-training, and vice versa. But we actually don't talk enough about the infrastructure, like the real thing, the real layer that actually like all the models and all the algorithms are actually run on. And today we are going to host Benny Chen. He's the co-founder of Fireworks AI, one of the fastest inference platforms out there. Hi, Benny.
Hi. Hi, Ravi. Hi, Ellen. Nice to meet you.
And
Nice.
as always, we have Ellen. Hey, Ellen. How are you?
Good to see you again, Ravid, and really cool to sit down with one of the titans right now in AI inference.
So, Benny, I think like let's start from maybe from the beginning. What does it mean actually, infrastructure for AI, or like infrastructure for training and inference for AI?
Absolutely. So there are many layers to having a there are many layers to be able to support a large inference workload. At the very bottom, we want to make sure we secure enough GPUs of the right type for the right model. Because we support so many different models, we need to make sure there are all sorts of different GPUs. Sometimes sourcing is also difficult, so we need to make sure we source from multiple vendors as well. And then on top of that, we need to make sure they're very performant kernels for those models. And again, sometimes these models are from different model architecture, so then it is very difficult to specialize. And it's important for us to pick our battle on which one to specialize on. On top of the kernels, we have our runtime, uh, which because we're a PyTorch shop, a lot of it is Python based. We heavily emphasize speed of execution, so we still try to keep everything in Python as much as we can. Um, but yeah, and then on top of that, there's the routing and the virtual cloud layer, where we have to abstract all the different components away from our customers, all the different neo clouds away from our customers, so then they can just enjoy one inference endpoint. And then we do all the failover routing for them. Yeah.
So okay, so you're doing like all the infrastructure layers, but at the end, I think like I don't know. The naive question is to ask, okay, why not to do it by myself, or why now I'm not like I don't know, an AI company that wants to train their own model. Why I actually can't like just buy the GPUs and make it by myself?
I think that's a very legit question. I think number one is buying GPU today. Even a statement as simple as that is not as easy. No one figured that would be a hard thing to do, but that's the state we're in today. So working with Fireworks or a company that has scale and have enough buffer is often easier for our customer to scale up versus working with the cloud providers, which may or may not have the availability in certain regions and whatnot. On top of that, like a lot of times, it is very difficult to figure out what are the right type of optimizations and what are the right things to set up for failover, what are the right things to set up for caching, all those stuff. If you can afford a very big team in-house that can do this constantly over many years, I think that is fine. What we often see is that the competition on the application layer is absolutely ferocious. So all the application companies are laser focused on making sure that their application can succeed, and infrastructure is not one of those core competency. And we help take care of the infrastructure layer. On top of that, there are many very AI forward digital natives, or and you would even call some of the traditional enterprise. Those are very AI forward. They may not have the capability in house. They may want to build it, but in the current stage, I think it's still strictly better for them to work with a vendor like us who can help them get started, and they can figure out all the higher margin work to automate their workflow or improve their product while we take care of the infrastructure. At the end of the day, infrastructure really is a game that benefits from having scale.
So how many, like, I don't know, GPUs? Are you working only on GPUs, right?
Yeah, absolutely.
So how many like GPUs like you actually like need to manage? How many GPUs you have that like you need to understand how to?
Tens of thousands to hundreds of thousands. I think that's something I can share. I think we can. I think we can also share that. I don't know how fast this one will go out, so I just double checked. I think we can share that we run about like 20. I think 26 trillion tokens a day. I think that's the latest number that we're gonna share soon. Um, so 26 trillion tokens a day, that is bigger than OpenAI and Gemini's API. I don't think Anthropic shared any numbers. I bet Anthropic's API is bigger, but we run many, many tokens through our system. And a lot of it on open source and customized models, and we're very proud of that. And we really think that getting to scale for inference helps everyone. We have the best technical chops in house. Other people have demands that need to go to many regions, need to have all sorts of different model types, and we help sort of institutionalize all those knowledge and share with our customers.
So, have you been seeing hardware inflation in your own costs of doing inference? And do you think if you are experiencing it, that it will be a durable kind of phenomenon? In particular, even like, are you experiencing it on old GPUs like A100s?
I think it depends on the vendor. But in general, yes, the price of GPU has been going up. Um, but my understanding is that a lot of those may not be going up in the per hour dollar. It might be going up in terms of like a duration of the commit, as well as the amount of prepay. So like structurally, the cost may or may not look the same, but the commitment and the duration risk is different. Whether it will go up indefinitely, I think that's ideally something we don't have to think too hard about. Um, so the nuance I think is the following: the revenue for fireworks is definitely capacity constrained. It's not a demand constrained environment. I mean, like you can see it on like every layer of our economy, right? Like the demand for automation and tokens are really taking off. So I don't think it's going to be demand constraint in the short term. Whether the price will continue to go up is whether it will be demand constraint in the long run, which may or may not be true. Like I think it really depends on whether we can actually turn up all the GPUs that many cloud have committed to. Um, there's a lot of complexity in terms of dealing with local regulations, dealing with power grid, dealing with brick and mortar infrastructure that you need to overcome to spin up data centers. And people are also doing it at breakneck pace. Just for context, like when I was at Meta, we worked on a like in 2017 we worked on a chip that was a sort of Meta's like first attempt at custom ASICs. And I remember very clearly at that time I was pushing very very hard to have the chip like end to end shipped and validated in 11 months. And everyone said I was very annoying. I was one of those annoying ads people who like demanded unrealistic things. And now you're talking about like Colossus that's getting like spun up in like 3 months or something. Right. And it's like we forgot like how fast we used to move. And we like the Meta people worked very hard. It wasn't so much so that they weren't willing to ship everything in 11 months. It's just that at much faster pace, the cost is much higher and the risk is much higher. And it's not very clear to me whether all the committed projects will go through. And if there are many projects that doesn't go through, then I think the supply constraint will continue to happen for quite a while. If all those projects do go through, then I think the supply picture will be much better. So I think if you are a analyst somewhere, it will help me a lot to inform me like which project is real and which project will just get blocked by the local government like forever.
Well, and then related to the specific questions maybe around data center construction, success or not, what do you think about like Nvidia versus AMD versus TPUs and the general hardware world we're in? Do you still think Nvidia will remain very dominant, 5 years from now, or and similar?
Nvidia will definitely be dominant in 5 years. The hard thing these days often is securing enough power, and Nvidia and Google are the ones that have capability to secure a lot of power. I think AMD volume will continue to grow, but for sure, like GPUs and TPUs will continue to dominate because they have the relationships, they have the commitment to be able to say, hey, like I have n number of gigawatts gonna get spun up. I do think that's one of the questions that a lot of I think ASIC startups need to figure out whether they can still secure enough power to ship their chips while the CSPs have most CSPs have their own ASIC.
And do you have also like TPUs?
Not a lot.
And so what do you think about like, I don't know, combining them, like even combining like different versions of GPUs? I know that there are like some discussion about Colossus, right? That like it has mix between H100, H200, like all these things, and like it's apparently it's much harder to synchronize between the different GPUs types. So what is your take on it?
Can you repeat the last part of the question
So
again?
yeah, what is your take like about like how like do you think like in the future like it can be like data centers that combine different types
Oh, yeah,
of
yeah, yeah.
GPUs and
Yes, yes,
different
yes.
versions, different generations?
Different version and different generation is slightly more nuanced. I think your question about like different types of GPUs, I think that will definitely be real. The like Nvidia itself has like prefill focused chips versus like a generation focused chip after the Grok acquisition. Um, and like I think like building prefill focused chips are definitely more interesting and slightly more in line with what GPU looks like. And then for like so then you have like training chips and you have like inference chip that is more focused on prefill and generation. Um, I do think one really big nuance that people don't get into is how much specialization are you actually looking for? Um, because I also used to do a lot of sort of like capacity planning for Meta. One big question we always ask ourselves is like training inference fungibility. You can definitely have, let's say, like 20% or 30% of your capacity dedicated to training, like 30% dedicated to inference, but you always need a buffer in the middle that can be fungible. And in a world where utilization and slash capacity is the main bottleneck, how much do you want to commit to certain specialized chip versus something that's fungible? Um, I think it's very, very hard to tell. And if you ask me, I would prefer fungibility because I would prefer fungible capacity that I can run at like 95% utilization versus a specialized chip that I can only run at like 50, 60% utilization throughout the year. Um, because at the end of the day, idle capacity is money. So I think that's sort of like a judgment call. And for companies that have clear demand for either inference or for training, they can procure dedicated capacity for those. But there will always be a big, big buffer in the middle where you can use it for both.
So like we talked about demand, right? Like that there is no enough GPUs. But do you think okay? So this is like the first layer, and let's say that we get enough GPUs or TPUs. What is the next step? What is the next layer that you actually need to build?
The next step to build, I beg your
Yeah,
pardon?
let's say we started the talk, right? That you said it like, okay, so if I want to build to get to run my own models, like
Mm.
these are the difficulties that actually
Yes.
need to take into account. So the first one is we don't have enough GPUs, right?
Yes.
Let's assume that we have enough GPUs and we build and we have some data centers. Like how we actually, what is the next step that we actually like need to do? What are the layers that we actually need to build on the top of it, right?
Nice. For both inference and training, I think interconnect is a very big topic. So let's say let's say you got a building and then you powered it up and you roll a bunch of racks in. What's the next step? Um, so I guess like every company has slightly different internal tooling, but at the end of the day, how to connect these things together is very, very important. I think OpenAI recently went public with their MRC architecture. Like they had many redundant NICs per GPU to connect things together. And then you also have to have networking in-house to make sure you connect these GPUs effectively. Uh, Often what Fireworks operate in is data center that's rented from other people. So then we also have to deal with all sorts of different networking, sort of like a control plane infrastructure as well. Some are bare metal, some are Kubernetes managed. Also different storage technology for training, like some are NFS, some are blob storage, and we try to abstract all that away from our customers. At the end of the day, like Fireworks does a lot of RL and training workload for our customers, so abstracting those away are very, very helpful. And then like scaling up also means like you have to figure out how to download models and download images very quickly. We have a lot of P2P technologies to download models and download images. And then you have the networking layer on top to make sure you can connect all these serving and training chips together to be able to support the workload and auto scale very quickly.
And
And then for the scaling problems that you're talking about in general, do you think, also related to the data center design problems, we've been seeing, some people arguing that model architectures would stay sparse mixture of experts forever, but a lot of the Chinese model releases recently have been releasing simultaneously dense models and sparse models. I'm personally part of the, I think dense models are better. And, I study log probabilities a lot for sampling research, and I find dense models have better appearing log probs. I'm just wondering, do you have opinions from a data center perspective on which architecture will be the dominant one and what's easier to do hosting and model inference serving on? Like, what do you want to win?
I think that's a interesting question. I think the current consensus is MOE, not because it may or may not contradict your study. What's the right way to put it? At the end of the day, every chip has a ratio between how much bandwidth you have and how much compute you have. That ratio is sort of the ceiling that the model designers have to hit. So when I was talking about like utilization problems on uh, whether uh, whether I prefer fungible capacity across training inference because I want to run everything at like 95% utilization, the model designer has the same problem where they have n number of chips for next year. They have to figure out what's the best way to use the chips. And MOE is just the most efficient architecture for large batch size on GPUs. And even if like in some cases that dense model would behave better, they don't have a choice but to adapt to the environment. So it's like a evolution kind of like selection bias where like if you try to select for like whichever architecture that fits the environment the best will survive. And that environment is giant data centers with GPUs. I mean, if the world was born with like let's say no HBMs, I'm sure it will look very, very different.
so so do you think like there is something that can be close to it? Like what will be like in terms of like, not in terms of like performance, but in terms of like efficiency, if you want, behind the mixture of experts? There is something that you say like, oh, this is something that like we should prepare to serve or something like that?
I think the most recent one, the more interesting one from DeepSeek is engrams, like embedding table lookups. I don't know if people need to do things to prepare to serve them. It's more like these model architectures will sort of max out the GPU capacity as much as they can over time, and we just need to adapt to support those architectures. The other nuance is long context and how to support long context efficiently. Um, that's something the inference providers like us work on every day. And then on the training front, with longer and longer context, it's definitely getting more and more complicated. So when we support our customers on training and reinforcement learning workload, it is definitely getting more painful every day. But I think it's also very fun to figure out how to support those workload.
About quantizations, do you think like, I don't know, FP4 training is something realistic in
Oh,
2026?
yeah. I mean, like DeepSeek also released a paper on to teach everyone how to do it properly, right? I think the more interesting question is that is there anything beyond FP4? And someone still need to educate me on if this is the end of the quantization game. Because it's a little bit hard for me to fathom like how to train on like FP2 or FP3. And then if this is the end of like quantization game, I think maybe some of the free lunch will be over.
And somewhat related question also, because they presented their work at ICLR 2026. TurboQuant got a lot of excitement from analysts due to a Google blog post about it, but it has serious academic allegations of misconduct and outright fraud posted on like the open review. Do you have opinions about TurboQuant? And if I'm right about TurboQuant not being any good, do you have opinions about like alternative quantization, like even inference time quantization methods, and also things maybe not at training, but like they've squeezed down to 1.58 bits even a year and a half ago. Do you think
Mm,
there's a limit with inference time quantization?
I don't have context on TurboQuant's like academic stuff per se. I do think there has been a lot of exploration in the open on how to do quantizations. I think the survival the fittest theory still stand in the sense that like integer quantizations are not as friendly on GPUs. So then you need like special kernels for Kimi for like int4, whereas like all the NVFP4 stuff sort of just fits the hardware very well. So any quantization techniques that don't work on uh, Blackwell at scale will not survive and for long. Um, but that's not to say that the technique is not good. That's just to say that in like a very competitive world, people will converge towards whatever that's supported on the hardware itself. And these researchers can be very, very talented. It just that there may not be as many design freedom for like the best model as they want to have. So maybe in like a few years where there's a lot more redundant compute and there is more sort of room for people to play with those integer quantization techniques. But for now, like I think it just has to be whatever NVIDIA supports. I do think that is different for TPU, different for people who work on different ASICs. Maybe for like TPUs, a lot of people do like diffusion architecture much more than sort of like other architectures. Maybe for TPUs, like Int8 is more friendly than FP4. Um, so then like maybe like for on those chips, like integer quantization stuff makes more sense. But then it's just constrained on whatever that's provided on the supply side. I guess
So
it's a little bit sad when I put it that way. Sorry, go ahead.
no, like I have like similar question. Like, how much you think is like the current software stack, like the algorithms, are tied to the infrastructure? I don't know. Do you think like the fusion model can be something that actually like people will use in practice in large scale, based on the current limitation of the hardware, or do you think we will keep these like next token prediction, autoregressive models with the layer structure, like training them with HGD, like all these things that basically based on the current version of TPUs?
I think there are many layers to your question, like the loss function architecture. So like guesses for what next set of changes will be. I will try to answer them separately. Guessing what next set of changes will be, I think, like both like Chinese open source and American open source model talks a lot about like their training recipes and whatnot. We see it from like Nemotron, we see it from Allen AI, we see it from DeepSeek. A lot of it just like how to push the boundaries, and if you see how like crazy all these DeepSeek people's kernels are, like honestly, like when they came out with DeepGEMM, I was like so shocked. I was like, I thought gems are done. Like I always assumed like Matmos are something you take from Nvidia, and then like maybe Fireworks does a lot of bit of in-house customization, and it's about it. I did not expect DeepSeek to just come out and be like, hey, there's like a new gem library that you should adapt. That's very surprising, honestly, for me. DPP, I'm not surprised. Like MOEs, of course, you need something different. Just gems, you need something different. That's new to me, at least back then. But I think like the more I like follow these people's work and also like follow what Elon AI people does, a lot of it is just their hardware constraint, and they try to make the most out of it. Um, so it depends on what hardware these researchers get stuck on. If they get stuck on the GB300s, I'm sure the work will be very, very different from the DeepSeek people who are stuck on hoppers, right? Like the hopper kernels, the very best kernels that come out of DeepSeek. So it depends on the constraint. But I think the second part of the question is, what was it? I'm sorry, I forgot. I'm blinking out on the second part of your question.
So about like what are the paths that are actually like related? Like, do you think that we will see like different types of algorithms and different types of like
Oh yes, yes,
of
yes.
the
You
software
asked
that
me like next token prediction. Um,
yeah.
I think next token prediction is a very good formulation for reconstruction loss. What I mean by that is when you teach a kid how to draw, at least when I was learning how to draw, I don't know how other people teach it, but when I was learning how to draw, I was asked to sort of recreate a bunch of fruit like apples and grapes on my canvas, um, and that was the measurement for how good I am for drawing. And of course, like modern art is very different and whatnot. Don't grill me on that. But I was told to reconstruct what was in the real world, and also in the exams and whatnot. Like a lot of it is like reconstruction of what I used to remember or things that I see in the world. Um, and next token prediction is a form of reconstruction loss. For like image generation, there are other form of reconstruction loss. So for sure, the loss function may change over time. I think the overall guidance on like reconstruction loss and verifiable rewards, that like thing will not change. What will change, I think, is the reconstruction loss is incredibly like during like pre-training is incredibly efficient. Uh, not
In
in
what
like
terms?
dollar. Sorry, go ahead.
No, in what terms? Like, what do you mean inefficient?
Yeah,
Efficient
it's
can be
like
in
a
many.
very dense reward. And like at every step in time, you're getting something different. And you're like like every token that you predict that is off, you have a number at the end of that training and be like, hey, like this is the models are predicting or memorizing these things well. Um, right now the RL algorithm honestly is incredibly inefficient. Like you get one scalar at the end and you try to adjust the whole trajectory. Um, maybe you're supposed to have a process reward and whatnot, but those are very, very hard to set up. That's also easy to hack. So I think it is gonna be different for RL. That the RL training efficiency should go up, and ideally to a point where it can be as efficient as pre-training and whatnot, as like next token prediction. but I do think it's it's long overdue. And I would not be surprised if people change the R algorithm to be something that is way more efficient. But for next token prediction, I think, or like for example, if they train like image models, they will also have other forms of reconstruction loss. I don't think those will change. I think they will stick around for a long time.
Do you think that these there's more like software innovations that will come out? Like I've seen a lot of cool stuff involving speculative decoding. You know, first of all, being able to not necessarily need to match the tokenizer between the draft model and then the other model, and then now we have the same model being its self speculative decoding, basically, as they're calling it, which is like the latest innovation getting merged into so many of these providers. Do you think that we're kind of squeezing out like most of all the efficiency already, or do you think that there's just a lot more free software optimizations? And then furthermore, what do you think AI's role is in the discovery of these? Like, could you do AI generated kernels that are anywhere near the quality of DeepSeek, for example?
Okay. It's like a very interesting multi-part question, like auto research, auto kernel gen, like newer techniques, and also like
Self-improvement models.
if there's a ceiling, right? For newer techniques, like because Fireworks does a lot of training for our customers as well, so we do see a lot of like different forms of sort of speculators and how to train these speculators, as well as like how to co-train these speculators when we support large model training at scale. These things are definitely something Fireworks work on every day. We do think that there's still gaps between open source and what Fireworks provide. At the end of the day, like our speculators look different from whatever people have in open source. Um, so that I think there's still like things that people can improve on for sure, and there's a lot of things we can improve on. And but like your other meta point was, I think your question was trying to hit on inference. But I do think like we see a lot more interesting things during training, where people customize their loss function, people customize how they do the training recipes, and how we support that with different training setup. Like for example, in our training API, we also sort of borrow from the inference idea of like just replica and horizontal scaling to training. So then people can just specify a higher replica count and then just like horizontally scales. And that has been like very useful for a lot of our customers. Um, and then like more underlying kernels also different. Like so, I think like on the training front, there's still a lot of like interesting things to explore, and we work with our customers a lot on those. Um, and then for the sort of auto research kind of idea, um, I do think if you believe in AGI and you believe like in 5 years we'll all be out of jobs, then the only question is when. It's not whether it will be better than human. I think right now it still does like stupid things from here and there. But I think it is getting hard to tell whether it was authored by a human or by a very experienced kernel engineer. So I believe in autogen, and I think like how we work today effectively is very close to autogen even, because I mean we're using Cursor every day, so uh, who's not to say that it's already auto-generated today just with like some human guidance? And then the only question is like how automated can we make it end to end? That's something Fireworks trying to figure out every day, and I think it will be a interesting exploration for sure. But yeah, I do think like auto research may be the most open-ended one. I do think there's a lot of like excitement on Twitter on like so like Kapathi's auto research stuff. There's also like a lot of like recursive takeoff, those kind of like rhetoric. And then like you see in these interviews, and these people are always like, oh, the researchers will be replaced first. Um, I think I think a lot of it is marketing. I honestly think a lot of it is marketing because let's say you believe that. Let's say you believe in the 70s and you believe like trading will get automated by computers. And you believe that all the traders cannot trade as fast enough as the as computers. Does that imply like if you fast forward 50 years, like the hedge funds will be gone? I don't think so. They just get paid like crazy and they have to work on the most difficult things that is not automatable, right? Like there's always going to be some task that is out of distribution from these frontier labs. So then if they don't cover in their evals and they don't cover in their RL training, there still has to be humans who are incredibly sample efficient and can adapt to the gap that the model companies leave behind. So then I think you will see this like ladder for the next 5 or 10 years where there's like a gap that the frontier labs haven't trained on. The humans will come in and fill it. And then the only question is like, is there going to be a gap in 20 years? I think there still might be some gaps. One thing I always ask myself is all the multimodal vision stuff. Like, how expensive will it get for it to be as efficient as human? Like, I don't know how much how many of your friends worked on like live streaming sites. I don't know, Twitch or whatnot. For Facebook, it was incredibly hard to do streaming. And I sort of always assume you just run FFmpeg on the server and then like everything's done. No, like FFmpeg will offload to some GPUs and then you should be done, right? No, it turns out it is incredibly intricate and complicated, very bandwidth heavy, very hard to maintain. So then if you sort of like ask yourself, how far is it for these AGI models to be as good on like vision tasks as humans? And then like can it be as power efficient? I think that's very hard because intelligence may be something that the world has developed for like, I don't know, 100,000 years. I think vision is like tens of billions of years. Like it started like at the very beginning, and all the vision components are super power efficient. So I don't know how you can make silicon as efficient as all these like carbon-based vision components. So then if vision is always going to be prohibitively expensive, I don't know how it's gonna work on the model side, and like I think maybe on the perception front, there's always something that human needs to do to fill in. So that's a slightly anti-AGI stance, but I do believe all the text work will get automated away, but it doesn't mean the vision task will be as cheap.
Yeah, I must say that I quite agree with your opinion. So what do you think about the hype? You know, like you see a lot of companies and use cases and startups as part of your job. What do you think about the current like status of AI and like specifically the hype with AI and LLMs? Do you think it's like and reasonable? Do you think like there is like specific components that people are overhyped or underhyped?
Yeah. I honestly think it's still underhyped, and it might be contradictory to what I just said. I think all these startups would turn all the text and all the information I said is inefficient for LLMs into LLMs as clutches. Oh, sorry, clutches is like the not so fancy word these days. Harness is the right word. So all these harness companies will come in, take charts into text, parse PDF into text, and then like the model can just run with it. I guess the reason why I say is underhyped is I definitely lost a lot of money gambling crypto on like decentralized exchange and buying a lot of NFTs that will never see the light again. And I think at least compared to crypto, I feel like it's still incredibly underhyped. Um, I don't mean crypto. I don't mean Bitcoin. I mean like all the sort of like a higher level abstraction built on top. I do think that there is still a ton of industries that hasn't been disrupted by LMs, and it's still an incredibly greenfield kind of setting for a lot of companies to get into. Because at the end of the day, like a lot of people don't like their jobs. They don't enjoy what they're working on, and that as long as that still exists, that there's always an opportunity for some startup to disrupt that kind of field where honestly the people will be happier that not doing such repetitive work. The employer will be happier because it's cheaper. And until that stops, um, I think there will still be room for improvement.
Yeah, you know, like we talked with Alex Imas. He's a professor at Chicago, and now is like I think he's starting at Google. He's like studied the relation between like AI and the effect on the labor market. And like he says, at the end, like there are so many assumptions that we need to make in order to predict what will happen, to different jobs and different types of works. And we can think about different scenarios, but there is a huge difference between that you need to automate a specific task, right? And this is easy, and to automate like the job, right? That like contains many tasks, and you basically need to automate all the tasks that this job is doing in order
And
to automate the job. And it looks that again, at least in the near future, we will have most of the jobs will have tasks that are not automated, and there is still like some bottlenecks that we need to understand how to do.
Yeah, I think that makes
Um,
total sense. Yeah.
so yeah, maybe let's talk a bit about the difference between training and inference, right? Like, so first of all, why there is a difference between training the model? So if we had for someone in our audience that it doesn't know, like you have basically models, you're trained them, and then after you train, at least in the current paradigm, you're using you call them, and like you're calling like some questions or like whatever, that this is called inference. So why there is a difference between training and inference in the infrastructure level?
At the end of the day, training doesn't need to update weights. Conceptually, you think of it as like forward pass in PyTorch, where just like a bunch of forward passes. And because you're not updating weights, there's a lot of room. You can wiggle around. You can do all sorts of crazy things, and you can have all sorts of optimizations applied on top. Assuming it will be sort of like frozen weights, and then you just keep on running through those weights over and over again. For training, the only difference is you're updating something. Um, so for our audience who don't do model training every day, there's something additional called backward pass for training, where you have to sort of like do all the autograds and making sure you run the math to figure out how to update the tensors, but then you're doing some update. So then because it's dynamic, it's a process that you need to keep on iterating. There are more room for failures or room for things that can go sideways, and you need to take care of those upfront as much as you can. Um, on top of that, because you're doing updates, it's much more memory intensive. So you have to figure out how to sort of like horizontally or like vertically like place the model differently. And when you place the model differently, the communication pattern changes. The performant kernels that may run on certain settings may not be as performant in other settings. Same for sharding schemes. So all those things has to change, and then you have to figure out how to adapt. Fireworks is like I do think is like a very interesting place where we run both training and inference and RL workload on top. So we have to balance all these different components all at the same time. Um, but yeah, at the end of the day, inference is only forward pass. On no way update, you can do a lot of interesting things in that setting. Uh, on training, there's a backward pass. The interesting thing changes, the communication, the workload pattern changes, and you have to adapt. In RL, you have to do both well at the same time, so it's extra interesting on top.
And what is harder?
I I don't know what is harder. I think scale is always hard. It's 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 almost like the old world again. It's like I don't know why it reminded me of like Ford in the 1910s of like kind of scale production and whatnot. I do feel like scale is always hard. So I have a lot of respect for all the CSPs and all the big players in the field, because there's a lot of things you need to work through to scale things up.
And when you say scaled, like you mean like what? Between different GPUs, different nodes, between different like data centers, like what? type of
Yeah,
scale?
absolutely. Like a lot of that, like differences in hardware because we're supply constrained. We may not always be able to pick and choose the hardware type we want. Like between different data centers, like one interesting work we had with Cursor that we went public with is also cross region training because it is not straightforward to procure one data center with hundreds of thousands of GPUs, and there aren't as many Elons as we would like in this world. So then we have to figure something out on like how to connect like GPUs from like I think at the end like 4 different data centers together. So then we had a blog on like Frontier RL is cheaper than you think. Basically, we were able to hook up like 4 different data centers, and then we were only passing like compressed deltas across them. Um, and then as far as we know, like I mean, we worked on for like maybe like a year or two at this point. As far as we know, like Gemini and OpenAI also have same settings, but outside of these frontier labs, I think Fireworks is like a unique place to have these kind of offering, and that was important to help support our customers like Cursor to be able to scale their training to like multiple data centers. So I think scaling is always hard. There's always some bottleneck that you run into, and you won't know until you have to run through them.
And is there any role to play for like low rank adapters or steering vectors or attention engineering, these kind of more like niche techniques right now for like model fine tuning and all of these things?
I think that's a fantastic question. Like I think like sparse autoencoders, like the whole point of open source model is so that people can inspect it. So then like when I first saw like the sparse autoencoders idea on like, oh, you can like look at the hidden state in the middle and then like figure out what's influencing the model. I thought it would take off in open source models, but turns out everyone's just too busy like figuring out how to train and serve these models, and not enough people like spending time like doing inspections and figuring out like what are the intricacies in the middle. um I do think as we saturate in terms of performance, those things will have to come back again. And I genuinely think like training sparse autoencoders and making sure we can inspect those models will have a comeback, and there will be real open source collaboration between, let's say, Fireworks, who's training sparse autoencoders and looking at like this open source model in this dimension, and then feeding those info back to the model trainers. So I do think there's a lot of things that is still on the table for open source models. I think people are just too busy right now. I'm sure we'll get to it in like a few months. I'm optimistic.
And
I really don't think it's niche. I really think like Frontier Labs does a lot of like sparse autoencoder training.
Well,
do you
but I
think
oh, sorry. I'm just worried about like the safety implications, right? Which is why it seems like that tech doesn't make it to the general public that often.
I think safety may be one way to put it. I genuinely think it's just like Gemini has a lot more people, so these people can train the sparse autoencoders. If you actually do the count, Gemini has like 5,000, OpenAI has like 4,000, and probably maybe has like 3,000 at this point. So it's like 10K plus people on these frontier labs, maybe like 1,000 in private labs in total. Like the number of people who work in open source is actually like way smaller if you think about it. Like open source is more human constrained in this world somehow, right? If you tell me like open source project will have less hands on deck than closed source project for like a SQL engine or for like databases or I don't know, like rendering engine on those things, that wouldn't make any sense, right? But right now, because the money is so concentrated, it's actually more human constrained on the open side. And I do believe like Fireworks dedicate itself a lot to the open side, because I think like all these like Claude Code codecs, they will automate a lot of things. And if you really believe in everything will get automated and all the humans will be off work anyways, I'm sure the open side will catch up and we will train those autoencoders. And safety may be one aspect, but I do think it's mostly just understanding. Like the open source side doesn't spend enough time and manpower to understand the intricacies of these models.
also the frontier models, like you think open source models will be better and like reach the level of the closed ones?
I think in most steady state setup, um, especially for like a area that's like heavily contested, open should converge. Now, I don't think it's as easy for models because data is not open source. So when you're talking about open source, you're often talking about, oh, the code for MySQL or the code for Redis is open. It's not the final compiled binaries for Redis and MySQL is open. So then people can iterate on the source code and collaborate on the inputs for these software. What we see for open model these days often, other than like Elon AI and Nemotron, a lot of it is that the output is open. But what can I do with it? Like if you only give me the Redis binary, like if I want to fork it, I want to modify it, it's very, very difficult, right? Um, so I do think collaboration isn't actually as easy for open models this time around as before. But I do think like it will take many, many years, but eventually like the Nemotron Elon AI people will catch up and it will be a good thing for everyone.
Do you think also like in terms of compute, because to train these frontier models takes a lot of compute? Do you think it will catch up also in terms of compute?
I do think for open models is going to be interesting is the amount of compute for experimentation can be shared. So when you talk with these like frontier people, like they say like 50% inference, 50% training, but a lot of their training runs are not actually the final training runs. A lot of it is like experimenting on different ideas and see what works. If the experimentation part can be amortized across different companies and those ideas can flow back and forth, I think the experimentation cost can go down while there can be more and more like big runs on open source side still. And I mean, like Fireworks is also happy to help people hook up like 10 different data centers together to do training. Like we know how to do that. So I think it will catch up. I do think it is in the world where you're believing in like exponential takeoffs and whatnot. I do think it's very hard to predict like how fast it takes to it will be to catch up and whether it's possible to close the gap in the next year or two.
And do you think the performance or like the capabilities of models, like even closed one or like also like open source one, do you think they will like accelerate? The progress will accelerate, or like we will see something that like now we are in the peak, and from now like the derivative will get smaller.
I don't know. I didn't like Opus 4.7 as much as 4.6.
So I have a thing to say about that real quick. There's a paper that at ICLR that was predicting model parameter sizes. I forget how they're doing it, and they predict Opus 4.6 to be significantly larger in parameter size than Opus 4.7. And this isn't the first time we've had that. Remember, ChatGPT 4.5 was a really excellent but expensive model. So I'm glad to hear other people saying this because I've had a similar experience.
I think it's hard for users for Claude Code and whatnot to switch, but because I use Cursor every day, like I'm very used to like switching models. So I feel like I'm a little bit on the sensitive side on like if some models try to pull a fast and stupid one on me, I don't know. I leave my Anthropic settings on 4.6 still. It's just like it does like really weird things. I don't like it's like a little bit it like hallucinates quite weirdly. Anyways, if the free lunch is over, I think things will plateau out a little bit. I do think like, for example, like what was it, like Anthropic is buying books and then scanning them and then just burning them afterwards. I do think like there may be data walls that can be established through these frontier labs if they spend enough money. That data wall may or may not be something open source can replicate easily. But I think people also forget like what started this whole thing off was like Common Crawl was the internet, and there was enough on the internet for people to share. Maybe like as time goes on, and then there's enough on the internet that can be used for open models, maybe things will catch up. But you always have these pendulum of like people sort of like monetizing on like open data and open ways, try to like swing to their favor in terms of like a walled garden. But then like there will be a swing back at some point on like having enough open data. I mean you can burn all the books you want. Like I'm sure with like 60 billion humans, they will share enough interesting things and might be just as valuable. So I don't think data wars are also permanent. They do establish moats, and I think that's a very, very strong moat. Whatever side that is more piggybacking on like free lunch, I think it will eventually catch up. It's just a timing issue.
And what do you think about the compute itself? Do you think we will see a much better, like the speed of the progress will continue, or that we will see like much better GPUs, faster, because like we hosted the Schmiduger last week, and he said, no, like we still have so much space for improvement. Like we are far from some theoretical limits, physical limits, that will double the compute every 5 years and all this stuff. What do you think?
I think doubling total compute may be true. In terms of like better chips, I would love to hear from like ML researchers on can you go lower than FP4? Because if you cannot go lower than FP4, I'm afraid like some free lunch might be over.
But the physical ones, like let's instead of like don't look on the algorithms, like the physical chip. Do you think we can speed up the physical chips much more than we have today?
I think that's a hard thing to predict. I can be more practical. My understanding is that like even for HBM like 4E, like it's been incredibly difficult for both Samsung and like Hynix to deliver. And like Samsung is going more like in-house to figure out how to do the packaging properly, because now you have like way more pins and like the heat the expansion factor is much higher. Like it's hard to like keep it there. By the way, I'm just I'm not good at like supply chain. So like please, if anyone in the audience is better than me at that, like feel free to shoot me an email educating me on whether I said anything wrong. But like just HBM like for in general, it's been like a pretty difficult thing to deliver. Because like it's getting so hot that a lot of things has to be redesigned. So I do buy the argument that things will get faster for sure. It's not super clear to me what's the path to get there, but I'm sure like honestly like we're pouring in like $1 trillion a year at this point onto these semiconductor companies. They will figure something out. They will hire the best PhDs and they will figure out how to do packaging and be like, Benny, you're wrong. Packaging is not that hard. Like, but in the meantime, at least like right now, like I'm hearing all these difficult things, and it's like not super clear to me how to overcome them because they have like physics constraint on like heat. It's not super clear on like how you can change the laws of physics in your favor. I do think like alternative architectures may pop up if we truly run into these worlds. I think, for example, like Cerebra is going IPO soon. They do a lot of like
Today.
wafer scale packaging. So like it depends on like where the constraint comes in, and then like how do you overcome them. So yeah, I mean, like with $1 trillion into the system, I'm sure the chip will get faster. Whether it will be getting faster in cost efficient way or it will get prohibitively expensive, that I have no clarity yet.
Okay. We almost out of time, but like let's, for example, I have like several like final questions. Like what a belief about inference or training, like LLM, that is widely held in the field that you think is wrong?
I don't know who believes in what. I do think that data mode is important. I mean, like that's what I mean by like Anthropic buying all the books and burning them. We do genuinely believe that a lot of companies with proprietary data have durable moat, and we spend a lot of time training and serving custom models. So these customers can incorporate their private data into the model and set up a data flywheel so that their model can be better for their product. I think buying all possible knowledge in this world will be impractical. And if you believe in the vibes of like on Twitter, on like, oh, like a lot of Opus model heavily emphasize pre-training and whatnot, it does contingent on these labs like buying all knowledge, but I don't think they can buy proprietary data because it's not something you can purchase. And as long as that stands, I think open models and customized models still have a clear path to succeed in our society.
What do you think about all Anthropic announcements about cloud mythos that they provided to only like selective companies, and they have strong concerns about the safety? What do you think about it?
I think the curl author recently came out, right? I think it was like the Mythos people reach out. There were like 4 CVEs. One of them turned out to be real, but it's like a low level CVE. So I think the curl author has like the most balanced view on what was good and bad. So it is a better model. It's just not as like good as maybe like what was already like what was claimed on or available. But I do think the Anthropic people are incredible at go to market, and I don't think it is something that people realize how good they are. Because for this day and age, a lot of startup founders I talk to, they always complain, "Hey, like go to market is so hard. We think we have a good tech, but like no one would buy it." Well, like all these companies have their own unique ways of doing go to market. And it doesn't matter Mythos is good or bad. They already created the hype that is incredible for their company. And I don't think there are I don't think people give them enough credit on their capability for go to market and how much of their valuation is going to be, or like anyone's valuation is going to be tied to go to market capabilities. It's not sufficient these days to just have good tech. It is imperative that Fireworks and other startup like figure out how to get our tech to our customers. And if our customers' mindshare is like, oh, Mythos is like the next big thing, even though like it's not something that they can clearly evaluate and whatnot. I mean, that's a failure on our side. That's honestly why like I come to all the podcasts and come to and like try to show Fireworks as much as we can, because I genuinely believe like go-to-market capability is core to the company competency going forward. And like I honestly don't think people give them enough credit on the go-to-market side for Mythos. That was like some top-notch like operations. Like I honestly like couldn't have like done it better myself.
I agree. Some people will call it a great PR department, but we can call it also like go to market.
I'm not being satirical when I say like go to market capability is going to be core competency. Like I genuinely think like we are doing every day trying to learn how to do go to market better, and I genuinely think they have some of the best, because it's not just the Mythos thing. Their Super Bowl ads are also on point, right? Like, because I mean, like I worked on ads many years. Like I personally don't have as much prejudice against ads, but they were able to capitalize on that and did a really good ad, right? Like everyone was talking about the ad. The ad was so good that it pissed off Sam, and then like you see like him on Twitter like blasting him. It's like it clearly triggered him. Like they're so good at doing these ads and go to market functions. I don't think people give them enough credit. Like I think, yeah, go ahead.
Will Anthropic continue to resist putting ads in their own products, or because that's my concern, is that it looks funny now, but I don't think it'll be funny for Anthropic in 3 years when they renegotiate on it.
I'm sure they will figure something out and convince us. I don't think it will be hard. I don't think it will be that hard. But yeah, I don't know, but it's a topic I'm very passionate about every day. Because I don't think tech is the only core competency these days. Go to market absolutely is. Because like at the end of the day, like I mean before I left Meta, I worked on ads, and I saw how much CPM grow over the years. It was so expensive that repurchasing was prohibitive. Like for the people who are subscribing to Netflix or like Comcast or whatnot, their credit card expired. The only thing this ad does was supposed to just prompt people to renew their credit card so that they can like purchase this thing again. Even that was prohibitively expensive. I don't think people realize how expensive ads are these days. how much money there is in the system for ads. So I'm sure like Anthropic will come back and renegotiate and be like, oh, like we need to place ads because of safety X, Y, and Z. But I do think like the ads are so expensive. If you cannot figure out how to do go-to-market, you cannot grow. And Anthropic has this perfect operations, like a go-to-market team that knows how to do ads on Super Bowl, knows how to do these Glasswing projects, and like I think honestly their team is like super on point.
Okay, I think we are out of time. Anything else that you want to add, to promote? I don't know, hiring, whatever.
Yeah, please check out fireworks.ai. We have a lot of very interesting blogs for you to read if you're interested in the technical things. We also have a lot of case studies for people to look at for how to use open source models. At the end of the day, I give a lot of credit to Anthropic. We still want to live in a world where there isn't like a duopoly or somewhat. Like hopefully it's a fragmented market where open source model can prevail. And thank you so much. Thank you so much for having me.
Thank you, and thank you for the audience.